One of the vegetables in great demand worldwide is the tomato, which is used in the preparation of a wide variety of foods and represents an important source of resources for producers. According to studies carried out by FIRA, one of Mexico's greatest weaknesses as a tomato producer is the lack of suppliers due to the shortage of sorting machines. For this reason, we have decided to implement a tomato sorting machine by color, since this factor is a determining factor when defining the commercial value of the tomato. With the development of this machine, the producers will save extra cost of selected and packed of their products, as well as the cost of transfer to centers of collection to realize those activities. The manual separation of the tomato is done taking into account factors such as color or size, and depending on that according to the degree of maturity or the destination of the tomato. Sorting by color is an important process as it is one of the most important criteria related to fruit quality and is a determining factor in terms of consumer acceptability. According to studies carried out by CIAP, tomato production in Mexico is approximately 164 tons per year, which is a very exhausting and time-consuming process for the people who carry it out.
For the design of our project we have a lot of ideas, and that's why we have made several sketches as you can see. But we have some clear ideas, like the inclination of our process is important because we save us the use of conveyor belts. In the background you are watching a speed art of the final sketch where we separate our process in three stages. The first one is the hopper, which helps us to separate the tomatoes in 4 ways. The next one is the revolver box. This one contains our automatic process that separates the red tomatoes from the green ones. And finally, this pipeline system joins all the tracks onto where the tomatoes go to separate boxes. Now let's talk about our automatic process. We have 2 revolvers where we have 2 inputs and 2 outputs. The tomatoes go from the first stage to here, and with the help of a sensor TCS 230, we evaluate the color of 2 tomatoes, and we change the orientation of a door in the pipeline system before they are in the output of the revolver. The materials that we're going to use in our project are cast iron that is going to be used on the base structure and the walls of the revolver box, and all the parts that are going to be in contact with the tomatoes are going to be of stainless steel that is the favorite for processes that involve food.
In our project, we will transform the material in different processes, in which each kind of material needs a different process. We need to cut and weld for our material. For start, the steel will be cut by plasma cutting to give form for the hopper and the rods that the tomatoes will go through. For the revolver, we have the option of roughing by a CNC. The tubes will pass for the same process of cutting by plasma in case that it needs. For the iron laminates, we just cut with saw, and the same for the tubes with a cut of 90 degrees. The welding will be different for each metal. The steel will be welded by a TIG process with argon with electrodes IR 316L with 125 amperes, and for the iron we will weld by a cold welding with electrodes of 2.5 millimeters that works with 50 to 80 amperes. We will start assembling the machine with the base of the tubs welding each tub of the correct length. After that, and with the correct size of the iron laminates, we will arm the box where the revolvers, the motors, and the transmission will be placed. The hopper and the rams will be the next part to assemble, leaving a space of at least 50 centimeters. After finishing that part of the assembly, the last part will be the tubs where the tomatoes will go to be packaged.
Talking about the transmission, the machine comes with a little transmission composed by two gears, the first one with 10 teeth and the second one with 20 teeth. That means that we have a transmission 1 to 2. The force necessary in the machines consists in moving around 5 kilograms force, and the stepper motor that we are going to use just gives us a torque of 4 kilograms force. For that reason, it's indispensable to make a transmission capable of moving more than 5 kilograms force with no problems. Why? Because if we increase the number of teeth, we will increase the torque. Therefore, the tomato separator will be able to move 8 kilograms force. According with the studies made before, with this transmission we have a safety factor of 1.7, and that means that the machine will not have wear and no problems in much time.
Within the electrical part, we have connections of different types. This because we are using two different power supplies. One of them is a voltage source that gives us 12 and 5 volts with currents of 3 amperes and 40 milliamperes respectively. The next one is being powered by the previous one, and it is an Arduino Mega, to which all the signals and feeds of sensors and actuators are connected. Only one of them is powered by the first source, being also the signals located within the connections with Arduino. The gauges used within the circuits were established based on the NOM 001CD standard, which indicates how much amperage each wire gauge supports. In addition, within our entire mechanism we have different security measures. We have allowed the safe handling of machinery. The first one we find is stop button, so that in the event of an accident the electricity supply to the machine is cut off and directly stops working. The following is a thermoelectric switch, which will be detached from its connection by setting the current intensity indicated by itself, keeping all the connections safe from unexpected overloads. Next, we locate a limit switch inside a cover that protects the gears, which deactivates at least that part of the circuit, so that the gears cannot be replaced unless the machine is stopped. This preventing them from changing to the runs, which could cause the loss of any member of the user who is manipulating the machinery. Another benefit of our machine is that not spend many electricity, just 38 kilowatts per month, so you will pay around 107 pesos according to CFE.
The objectives are divided mainly in four: general objective, service objective, social objective, and cost benefit. General objective: to provide to the companies related with tomato marketing an automated machine of tomato separation to achieve an optimal state of quality and efficiency. The ripening time of tomato vary between 4 and 6 weeks. The machine is focused to do the separation process in an easier and cheaper way without wasting much time. Service objective: although the machine has a specific use, the field of potential customer is too extensive because this product is accessible to any tomato marketing company. In other words, this machine is usable for small, medium, and big companies in the tomato industry, as well as for tomato exporting and importing companies. Social objective: one of the most important things is the generation of all the jobs involved in building this machine. Behind a tomato separator, there is a designer who creates the idea, a welder who builds the complete structure of the machine, an electronic or programmer capable to program and connect, a machining and milling specialist working and taking care about the specification and details, a sales executive who is in charge of selling and convincing companies to buy the product, a dealer who ensures delivery, and finally, a person in charge of maintaining. Cost benefit. Doing a comparison between manual process and automated process, there are many benefits in the purchase of the machine. First, the machine is equal to two people doing the job at the same time, giving us 4 tomatoes per second, and the machine can work 16 hours continuously. As we know, a normal shift consists of 8 hours of work. That means that we need 4 people to cover 2 shifts, and the machine achieves them easily. According to the government of Mexico, the minimum salary is around of 123 Mexican pesos, and if we do an analysis for 4 months, we get that in less than those months, the owner is going to recover the money invested in the machine, even if we include the light and the maintenance costs.